Hello and welcome to another episode of Buttpluggin with qDot. This is going to be the fourth and final live stream of the Teledildonics 101 series. So Teledildonics 101 was made to kind of be like one of my full day workshops on Buttplug. So in the past four parts, this has gone from just learning about the history of teledildonics and different things about the butt plug library through how we build a simple toy control app. And in this part four, we're going to actually build a full-on Teledildonics app. So by the end of this episode, you will have the parts necessary to be able to bring up a web app that can control someone else's toy or can control your toy depending on which direction you go. All of the code here will be open source. It's already available on both Glitch and GitHub. I'll be giving URLs for that later. And most of this live stream is going to be spent on explaining how the system actually works, because it got a little more complicated than I was planning on, which is why there's been a month between the last two parts of this live stream series. So without further ado, let's get going here. Oops, here we go. And first off, I guess I should also say, if you have any questions or anything and you are watching currently, please feel free to post some questions on the YouTube chat, or you can DM me on Twitter and I'll try to keep an eye on that. But YouTube chat's probably the best way to do that. And other than that, I think everything else is in the presentations. So yeah, let's look at some slides. Welcome to Teledildonics 101 Part 4. I really just decided to put this together about 36 hours ago just because I needed to finish it. So to say that I'm ready to actually present all of this stuff's kind of a little ambitious, but we'll see how things go today. Go. This is it for this live stream series. After this, I'm going back to recorded video for a while because it's a hell of a lot easier to put together. So as a quick recap, who am I? I am qDot, or Kyle Mishulis. I go by many names, I suppose. I am the founder of Non-Polynomial, which is a consulting company around haptics, sex tech, and other technical topics. I am the project lead of the Buttplug open source sex toy control project, and I do a bunch of other stuff too that doesn't really matter. This, as I've said about 15 times now, is the Teledildonics 101 series. Learn to build a Teledildonics app for the web from scratch using Buttplug.js. You can also build an equivalent to this using one of our native libraries. Right now I'm pushing almost everything to be in our Buttplug Rust library. So that's actually out on crates right now, usable as both client and server. It's really awesome. And all the videos that I have here, all these four videos are licensed CC by SA, no non-commercial. So if you want to show them somewhere else, do your own Teledildonics workshop using these videos or something, feel free, have fun. They are only archived on YouTube right now. I'm going to be putting them up on Pornhub and the Internet Archive fairly soon, once I've finished, or now that I will have finished all of these. And there's also going to be a videos page on the main Buttplug.io website. Haven't had time to put that together quite yet, but that will contain all of the videos, links to all the repos, all the slide decks, and hopefully at some point transcriptions of all of the videos too. So everything will be there, because this series kind of works as a intro to how to use the Buttplug library. So it'd be great for people to use for that. So ways to get a hold of me. There are my Twitter accounts. My personal one is qDot. There is the Buttplug library account at Buttplug.io. And then there's also the MetaFetish account. MetaFetish is the sex tech blog that I run. It's been fairly dead for the past few years, but who knows, might bring that back at some point. I run a Discord server that has somewhere around 1,500 members on it right now. I would say maybe 3% of them are active, but it's a really good place for information about building different types of DIY sex tech and whatnot. There's a Telegram channel that is mostly furry trash, but if you would like to share pictures of cartoon animals in shock collars, there you go. Um, there are 3 GitHub orgs that I run. qDot is my personal account. Buttplug.io has all of the buttplug related library code on it. And then there's the Interface account. Interface is another brand that is basically all the applications that live on top of Buttplug. So Buttplug is for developers, Interface is for end users. Interface is where things like Interface Desktop, which is the sort of desktop version of the functionality that Buttplug provides, as well as the Game Haptics Router, the application that I wrote that reroutes Gamepad Rumble to sex toys. Those are both Interface-based products. So you can find all the code across those 3 repos. Finally, I do have a Patreon. If you are interested in donating to the project, I would first ask that during the COVID-19 pandemic, please give to the people that need it first. So any of your service or gig workers or anyone that's kind of helping you out along here, please shove money at them. And then if you have like deep interest in sex tech or need some sort of consulting or something like that, there's my Patreon. I normally deal with money and things like that through there, as well as sending out like weekly updates about what I'm doing in Buttplug. And that's also a much better way to get support than any other way, because if you're giving me money, I might actually listen. So to recap the past 4 parts of this series, and I will say here that there will be refreshers on all of this as part of this video, so don't feel like if you missed one of the last 3 parts, you just have to go watch them all and can't watch this right now. So part 1 covered a history of Teledildonics and the Teledildonics app design framework, which is a set of requirements that I've come up with to evaluate how we build remote intimate interfaces. I'll be going through all of those here in a sec. The second part was taking that framework that I showed in part 1 and building a simple toy control application with it on the web using Glitch and Buttplug.js. After we did that, I also gave an architectural overview of Buttplug. So this part 2 was preparing for part 3, where we actually built the application that we designed in part 2. So part 1, how the framework works. Part 2, how to design an app under the framework. Part 3, how to actually code that app using Buttplug and the design we came up with. And that means that we are now at part 4. Part 4, once again, there's going to be refreshers on everything I'm about that I just mentioned and I'm about to mention. And finally, we're going to take that application that we built in part 3, and it has, using our framework from part 1 and 2 for the design, our knowledge of Buttplug from part 2, and our code from part 3, and we're going to turn it into a Teledildonics application. So I'm not going to actually be live coding this time. In part 3, I did live code the toy control app. This application got a lot more complicated than I planned on, and I'm not real sure it would be great for live coding. However, I have heavily commented it. There's actually more comments than there are lines of code in the project now, so if you are interested in digging into the code, that will be accessible. But today I'm going to kind of go for a higher level architectural overview of how Teledildonics works with the system that I've built. Okay, so once this series is over, I'll be moving on to create a new series that I'm calling Teledildonics 201. So Teledildonics 201 is going to take everything I've done in this live stream and make new recorded sessions where I make new applications based on this framework that I've built. These will be both in JavaScript and in Rust. Because at some point soon, or what I hope would be soon too, the JavaScript will actually involve the Rust code base via WebAssembly. It's because I'm really trying to get down to just maintaining one code base across literally every platform if I can. We'll see how viable that is, but that's kind of the plan for the moment. Right now, Buttplug.js is still its own thing, separate from Buttplug Rest. So anyways, what are the types of things that I might build in the Teledildonics 201 series? Well, there's Telegram and Discord bots, which we get questions about constantly on my chat servers. Lots of people want to be able to build chat systems that do toy interaction. I'll be talking a little bit at the end of this live stream today about how that works, or how that would work with the system that's going to be built here today. There's also Twitter and Mastodon bot interfaces. I was hoping to talk about WebRTC in this live stream today. Instead, I'm going to be just using WebSockets because there's a few more things about WebRTC I've got to figure out. But WebRTC would allow you to do literal peer-to-peer Teledildonics, so no intermediary server outside of the stun server that does the connection matching. So you would just find someone else via the stun server, and then you're talking directly to each other. And that works through any web browser, which is pretty amazing. Also going to hopefully talk about working with games. The one thing that we get more requests for than chatbots is Unity plugins, and that's hopefully coming very soon. And then I'm sure I'll find other things to talk about too. So yeah, that's going to be the 201 series coming up in the days, weeks, months after this. About today's presentation, I'm kind of sorry in advance here. First off, yeah, there's a reason that this took a month to get from part 3 to part 4. First off, pandemic life just sucks. Like, everything takes forever now. Um, and that kind of sucks the energy away. It kind of makes it hard to build new things and present them to people. I also, while I was building the system, I did end up going a little crazy on the system's design. The good news is that there are now new structures built into Buttplug and everything. But explaining those actually requires understanding the internals of Buttplug, and there aren't that many people that do that right now. So there's going to be what I'm planning on doing is talking about interfaces first. And when I say that we're building a simple Teledildonics interface now, simple is only in terms of the interface itself. That just means that it's a one-to-one interface where it's like, you have a vibrator, someone else has a vibrator. You can control each other's vibrators, but there's not groups or anything else. It's just a one-to-one system. So that's where the simple comes in here, but the technical side of it is going to be a little bit more complicated. So when I am talking about that, first off, I'm going to show the applications. So if you just want to use this stuff and you don't quite want to have to learn about how to code it or whatever else, that's fine. You can totally do that, and I'll show all of how to use it, how to bring up your own instance of our application first. And once that's done, then I will be going into how does this actually work. And if you're interested more in the development side and the architecture side, you can follow along with that. I'll try to make it as understandable as possible. There's lots of pictures and stuff. We'll see how things go. So, let's go ahead and get into our recaps of the past few episodes here. So first off, gonna skip the Teledildonics history part. For that part, you can watch part 1. Not going to be a lot of that coming up here. The design framework, though, is very important. So there's, I think, 6 or 7 different parts to this. And these are all sort of components that we think about when we're thinking about technologically mediated remote intimacy. So whether you're building a Teledildonics app or a game that controls sex toys, or hell, it doesn't even have to, this does involve hardware, but you can take the hardware out of this framework and just use it as a general design framework to think about how to build an application. And hold on just a sec, because I forgot to post my announcement on Mastodon, where people are probably also going to want to see this. So, just got notified about that. And once again, if you have any questions or anything like that, please, or even just say hi in the YouTube chat. Let me know people are alive and watching, because all I have is a number that ticks up and down right now. Anyways, okay, so social media updated once again. Okay, design framework review for teledildonics and remote intimacy apps. First, we start with the user. So obviously we need to think about the user, what their wants are, what they're kind of expecting from our application. We need to think about the environment that the user is in, because this dictates how we might need to build or change our applications. For instance, with something that involves hardware, we have to think about, are they going to be at home? What is possibly their home situation like, or something like that, where they might have to worry about, is their hardware too loud? Are they having to hide things? Will they be using this on a desktop or a mobile app? Well, if they're using it on a mobile app, are they still using it at home, or will it also be used in public spaces? That's what I mean when we're talking about the environment. So what is the environment that the application is going to be used in? What is like basically that is everything surrounding the user at the time they are engaged with your technology. Then there is the link between the user and the toy. So this is going to be a physical link. Like how do they physically use the toy? Is it like a small vibrator? Something like this, or is it going to be like something larger, like the flashlight launch or something like that? So size of the toy, and then you got to worry about too, like where are the buttons on it, because like this is a vibrator that you can easily move around. This is a prostate massager, so this is going to be like in the butt right there. So that button right there, if they need to hit that, that's going to be behind someone. And also too, this is a Bluetooth toy, so if it's in someone's butt, once again, you're going to have to worry about where the radio is and where the host is, because this is the peripheral. The host is going to be your phone or your desktop, and if those are not in line of sight to each other, which they usually aren't when your like phone's up here and your butt's back there, then you've got a ton of meat and water for your radio waves to go through. And it turns out radio waves hate meat and water. So you've got to think about like, yeah, how is the user going to be interacting with both their controller and the toy? And this can even be outside of the technical parts too, just like where are the buttons on the toy? Can they get to them while it's in use? Things like that. There's the link from the toy and the computer, which I just talked about a little bit of if you have a smartphone or if you have a desktop, where is it in relation to the toy? This is mostly a technical side thing, where it's like, can they talk to each other, and then how do they talk to each other? What are the capabilities for the toy to like what are the protocol capabilities of the toy and whatnot. This is a lot of the part that Buttplug will handle for you when I talk about that later. Then there's the link to the user and the computer. So what is the application that the user is using to control the toy? And that's going to be mediated by whatever interface you give the user on the computer. For what we're going to be showing today, there's going to be a super simple web application that just has a whole bunch of sliders. So it's all buttons and sliders and stuff. Fairly easy to use, but still not incredibly ergonomic, just because I wanted to keep this as simple as possible. But there's lots of interesting questions about how does someone control a sex toy? Like, what happens if they need to lube it up, and now, okay, now they've got lube on their hands, but they need to like hit their keyboard or their phone or something like that. So all these things you have to think about in terms of the context of usage when you're building an application like this. Then there is teledildonics, so actually linking computers to other computers, so the network interfaces. This once again becomes a more technical side of things, where you have to start thinking about what's the network protocol, what's the security on that protocol, so on and so forth. And right now, when we are dealing with these systems, I'm assuming a certain amount of symmetry. So that means user on one side, user on the other side, basically using the same thing. We're going to kind of assume that like they both have vibrators and they're both using a web browser and whatnot. That's not the case at almost any time in reality, but we get to live in theory land here at the moment. So thinking like this is not always going to be a one-to-one match between users, like especially if someone is on their phone and someone else is on a desktop and has different types of access or something like that. So that's there can be asymmetry in here. I'm just going to assume symmetry for this design framework for what we're doing for the moment. Okay, and you'll hear me talk about this this term quite a bit because this is how I sort of frame remote intimacy and building technology for remote intimacy. It's what I call proxemic glue. So I go over proxemics in part one somewhat. Proxemics is the study of nonverbal communication as portrayed through bodies and their places in space. So if you've heard the term personal space, that comes from proxemics. If you've heard the term social distancing, that is hugely important in proxemics now, and that's where all these articles are coming from about like how do we deal with social distancing and what does being a minimum of 6 feet away from each other mean for our types of communication now and how we talk to each other. So what intimate apps, teledildonics apps, intimate technology in general manages is or tries to do is tries to be what I call proxemic glue. So the thing is, your app is not going to teleport another person into having sex with someone else like in a physical way that they would expect. The intimate technology is not a one-to-one mapping to physical intimacy, and it very well may never be. There's so many facets and details to physical intimacy beyond the audio visual, touch, taste, smell, environment, everything else, that it's very difficult to ever say that there's going to be like outside of having like the holodeck or something like that, that's very much the realm of sci-fi at the moment, that you'll be able to achieve that one-to-one mapping. And that shouldn't be expected. You have to build a technologically based experience that does its best to get the users as close as possible. Like you're still working through a reduced interface on a phone, on a desktop, through a web browser, through an app, that's not touch. Like they can't just like smear their hand on the screen or some shit. So you have to figure out how to build an interface in your app that will make people feel close. And yeah, you'll have hardware to help you. You may have audio visual to help you. You may have textual context of sexting or something like that to help you, but you still have to build the pipe that all that stuff goes through. And that's very important, and that's what this is about. Now, the nice thing is close is good enough in horseshoes, hand grenades, and remote intimacy apps, because especially right now, as we are in the middle of the COVID-19 pandemic, it's all a lot of people have. And that's why we're seeing all of these media articles about, well, here's how, like, did you know that there are app-controlled sex toys? And here's how you be intimate with someone, or can be intimate with someone over an instant messenger, over sex. Like people are having to learn how to sext. People are having to learn this stuff exists now. And it's all in an effort to get them as close as possible. It's not going to be the personal intimate space of two bodies together, but it's going to be close enough, and that's what you want to design for. So that's what this whole proximate glue thing means. It's like what your app is trying to do is fill that gap between two people, and try to get it as, for lack of a better term, as sticky as possible. And that's really kind of what we're going for here. Now, the apps that I'm gonna be showing today that I've built for this are a very minimum viable product as proximate glue. They are literally just allowing people to hook up and control each other's hardware. There's no other communication mechanisms here, unless they are some sort of emergent communication mechanism that someone figures out how to do on top of these interfaces, which I've worked on video games, I've worked in virtual worlds. Yes, someone will figure that shit out. But in terms of my design that I built this around, there's kind of this expectation of people will find some other way to communicate, be it Zoom or Skype or whatever else. And then they can use these systems just to control each other's hardware while they have those other interfaces. Now, there are certainly reasons to build all those interfaces together in a single package, but once again, that's a much larger scope than I want to get into for this video series. So with all that done, let's go ahead and look at the toy control app that we built in part 3. So this app is available on Glitch. You can actually come look at this with me right now. The URL is right there. It's teledildonics-101-part-3-app.glitch.me. So if I come over here and bring that up. Here we go. So this is the Glitch website for it. For those of you that didn't get to watch part 3, Glitch is this great website that allows you to build JavaScript and share JavaScript and web apps and Node apps too. So they can be a combination of Node and web apps. You can actually run full servers on here. We'll be doing that here in a second. So I use Glitch a lot for educational demos and things like that, because it's very easy to take the code and remix it and whatnot. So remixing is Glitch's term for forking, basically. But usually what you build on Glitch is just small sample projects that people can just hit a button and then go start playing themselves. And for the past couple of weeks, I've had people doing this to beta test the Teledildonics app that I'm going to be showing. So it's been super, super handy for that. Anyways, so our simple control app was just literally an HTML file and then a JavaScript file. And there's only about 100 lines of JavaScript. Most of it is UI. So all of that right there is just bringing up the interfaces. The actual sex toy control parts are super, super small here, like 1 or 2 lines each. So this is just the fun of working in raw HTML and ES6, ES7. I didn't do this in TypeScript, mostly because I wanted to keep it simple. And the nice thing is too, it's like you get these 3 files, the HTML, the CSS, the JavaScript, and you can put them on your file system. This runs anywhere, and it uses web Bluetooth also. So I should say all the web apps I'm building here are going to be in Google Chrome, because that has web Bluetooth. So it's just one less step to hook up to a toy. You could hook these apps up to Interface Desktop, so if you wanted to use it in something like Firefox. Firefox does not have Bluetooth, probably never will. And but you can still connect out to Interface Desktop from Firefox to use these apps, but you would have to add that functionality. So once again, just trying to do this simple as possible, which is why this is this is Chrome only. It should work in any Blink engine-based browser. So I think it should work in Brave. I think it should work in Edge. But I'm just using Chrome here today for this. So with that out of the way, so here's the code, but let's see what this app actually does. So here is the simple Teledildonics app that we built. This is, the Teledildonics 101 Part 3 app. And to show you what I've got here, this is a 11th Dami wand. I need to turn on. There it goes. This is the 11th Edge prostate vibrator. This is a fleshlight launch, and this tube over here is the Vors A10 Cyclone SA. So these kind of these represent the three types of generic movement that are currently um, available in Buttplug. There's vibration, which is handled by either this prostate massager, which has two vibrators in it, or the Dami, which has one incredibly powerful vibrator in it. There's the launch, which oh, good. So the launch strokes back and forth, so it moves a fleshlight up and down. And then there's the Vors A10 Cyclone here. You put like a little insert in it, and it rotates it back and forth. There's a reason I call it the cock blender. So we'll see what we can get done here. I forgot to charge my launch, so it may die pretty quick. But okay, so to demo this simple Teledildonics app, first off, we hit start scanning here, and actually I'm gonna have to change to display. Okay, so one of the weird parts about this is the window that comes up for Bluetooth scanning doesn't show up on OBS easily, so I actually have to do a display capture instead of a window capture. But anyways, now you can actually see, or I hope you can see, the toys that are coming up here. So the P36 is the that's the Edge, and the Dami is the Dami. So let's go ahead and connect to the Edge here, and there we go. So where did OBS go? There we go. Okay, here we go. So now then. And as you can hear, and there's a bug in here that unfortunately makes things connect twice sometimes. There we go. Okay, there we go. So there we go. Okay, so yeah, we can connect to the toy and make it vibrate. And if I turn on the Vors here, and I think you can kind of see it from the light there, and then hit start scanning again. Not going to change my window this time, but you can assume that there was a Bluetooth window right there. Okay. And now you can actually see it rotating, and you can probably hear it too. And the thing about rotation is you can go either direction, so if we go negative here, it's going to go the opposite direction. Okay, so that's the Vors. And then I'm just going to hit reload here real quick and show off the launch. So for controlling the launch, there we go. Okay, so the launch will actually oscillate. So we don't really want, we want it to go back and forth without us having to manually control it every single time. So if I set this up like our min position and our max position, and the duration is how long it takes to get there. So the closer this is to 0, the faster it'll go. So if I turn on oscillate, you can now see, you can see the cup moving there. And here, if I move it, yeah. And usually this would have like a fleshlight in it or something like that. So that is our simple toy control app. That is all it does. It finds vibrators, rotators, and linear movement toys and controls them. That's what we spent part 3 building. All of that movement is, as well as all of the device finding and things like that, are handled by Buttplug. For this, it's done purely in the browser, so it is a just pure JavaScript, well, TypeScript library, but you can, and as you can see too, it does handle device disconnection. So as I turned everything off, it disappeared, which is pretty awesome. anyways, there's still some bugs in there and all, but it's a good first figuring out how to use and build stuff for Buttplug app. Let's go back over to PowerPoint here. So now that we've seen that, how are we going to build a simple teledildonic service with this? And one of the things that just makes me so happy about this, I I've been using PowerPoint for these for these slides that I've been doing in the live stream, and this was automatically like there's some sort of PowerPoint generation service now, and it generated this slide out of these. I don't know how, but it's perfect. So I just decided to use it. First off, what is a simple teledildonic service? What are we going to be building today? So we want to build a dyadic service. So that just means that two people can use it and can control each other's toys with it. So simple toy sharing just means you can click on a button and it will share whatever features the toy has. So if it vibrates, it's going to share the vibrator. If it rotates, it'll just share the rotator, so on and so forth. You could clamp down on these settings, but we're not going to deal with that today. Simple control, which is going to be just the controls that I just showed, where you just have sliders, and whether those sliders control your toy or another person's toy is based on the UI. Peer-to-peer if possible. I was hoping to do this in WebRTC, like I said. Unfortunately, this is in using WebSockets now, so every packet's going to have to fly through a remote server. But this was just kind of the easiest way to do it, and I hope the most understandable. So keep an eye out for that Teledildonics 201 series where I'll do it in WebRTC though, and you won't have to worry about anything but the stun server to match up. Finally, if this is complex, if this is simple, then what do we consider complex teledildonic service? Well, first off, that would be like a multi-user central server. So if you needed accounts or you wanted buddy lists or whatever else, or some sort of lobby matching, that would be what I would consider complex. You've got way more security requirements and issues to deal with there because there's so many people using that server and there's going to be attacks and whatnot. And this is not to say that's not a useful thing to know. It's just that would take far, far longer than the 8 to 10 hours that I was hoping this 4-video series would take. So we're going to go ahead and stick with simple for now, and we'll see about growing that in the future. And I will talk a little bit about how the system that we're going to be building is a basis toward those more complex things as part of the end of the architecture presentation I'll be giving here in a bit. Okay, with that amazing slide out of the way, like seriously, PowerPoint saw this toy and decided to put the teddy bear there, and I just couldn't not. I feel weird saying I love PowerPoint, but that's just kind of amazing. Okay, so now that we've done that, let's actually look at what the Teledildonics app that we're going to be analyzing looks like. So there's two places you can get this. First off, there is going to be the Glitch website, which is going to be similar to the simple Teledildonics stuff that I just showed. And then I've also put this code up on GitHub, so you can run this somewhere other than Glitch too. If you want to create like a Heroku version or something like that, people have done that. So it should just come up. You may need to, the one thing you may need to change is the environment file for passwords, but I'll talk a little bit more about that here in a bit. So let's go back to our web browser here. And okay, so as I said, this is up on GitHub. Full information about how to use it, what devices we support. There's the how to use it portions, how to set it up, and a few frequently asked questions. And also, as I said, the app is extremely heavily commented. So if you do want to get down here and really learn about how all of this works, I tried to make it clear what every single line of code means. So it's kind of like reading a novel. And if you do have any questions too, feel free to reach out. Happy to talk about this more, either on my Discord server or Twitter or wherever else. Just find some way to get a hold of me. Let's talk about what this looks like. Okay, so here is our simple Teledildonics app. I've got to let Glitch boot it up real quick because it's been idle for more than 5 minutes. Okay, here we go. So the way this app works is there is a local, which is the share toys with others. So you can take your toys, connect them to the browser, or you can tell other people to control your toys that you've shared. Now, the first thing that you're gonna have to do here is share a password. So in the glitch in the glitch interface, there's going to be a way you can set passwords up, and I'll show you that here in a second. And you'll have to do that when you create a new app. And we'll go over how remixing this app works so you can make your own instance of it, because making your own instance of this is part of the security here. So you'll need to know how to do that. But anyways, let's go ahead and connect locally. So if okay. Oh. There we go. Okay, so now I am connected. The only way we can really tell that is that there's a start scanning button now, and we can also tell that no one is connected to the remote side, so there's no one here to control the app, or control whatever toy we have. So let's start scanning, and I'm going to switch over again to display here, just so you can actually see what all comes up. So let's choose our dummy. And now we have the same interface basically that we had for the simple toy control app that I just showed. And if you want to control your toy right now, you totally can. So there it goes. So you have local control over this. Now this slider will not change while someone is doing remote control. That could happen, but I didn't program that in here because I just didn't have time, and this working in pure JavaScript and HTML kind of sucks. I would rather be doing this in TypeScript and a framework, but I didn't want to confuse people. So anyways, since we've got our toy hooked up now, there is this share control checkbox, and if we want other people to be able to control this toy, we would click this. However, let's go ahead and hook up to the other side of this first. So I'm just going to make another tab right now, and connect to our instance. So this is basically me acting as both the local and the remote in the same browser. I can do that. Okay, so I'm connected, and now over here, remote connection established. So if I share control here, I should now have a controller over here. See, and you can see forwarded connector, Levin's dummy v37, and there we go, Levin's dummy v37. So the local user has shared control with the remote user, and now when the remote user hits something, there we go. So this is loopback Teledildonics, basically. And this is our Teledildonics app. This is all of it. This is all kind of you really have to do here. So And if I unshare control too, this is one of the interesting parts. If you get sick of someone controlling it or you want to take their control away, you unshare it. Suddenly it's gone from the remote and you can reshare it. And it shows up again. And if you unshare it too, I think let's see, is this a bug? Ah, this is a bug. Okay, well you can always hit stop vibration too, but it does not actually stop vibration if you unshare, which it should. So that's something that should be fixed. But anyways, that's it. So let's go ahead and hit reload on both of these. And as you can see, this actually shows that the remote disconnected now. So there's some assumptions about this app that I made just to make life easier. First off, like you see, there's two passwords here. There's the local domain and the remote domain. So when you have this app, it is yours. This is not really like it is yours to share your toys with someone else with. It's not the way that I built this. It's not made as kind of a general just come to the website and anyone can share their toys with anyone else thing. This is very much a you own this instance thing. And so there's two different passwords. There is the local domain password, and this is your password that only you will know for being able to access this instance. So if it means that only you can use your instance because only you know a combination of what URL it's going to be at, which you don't have to share with anyone except the people you want controlling this. And even for the people that do know your URL, they aren't going to know your password. And I should mention too, all of this needs to run under HTTPS. This is Web Bluetooth does require secure contexts, so you can't just run this on HTTP. And so these passwords will always fly over TLS, and that's another big assumption about our security here, that the actual pipe itself is going to be encrypted for us. So, anyways, so you'll set up a local domain password that only you know. And then there's going to be how do you have someone your toy though? Now, in our case, for what we just did, someone what they need to know is the remote sharer's domain, and then the remote password. So the these are two things that you will need to share with someone. Now, if they don't they can actually have their own instance of this application, and they could type your domain name. If it's on a different domain, they can type your domain name in, but or they can just go to your domain and use the same interface, and it fills all this information in for them. But they will need to be able to enter this password, and you want to make sure that your local and your remote passwords are different. And if you're thinking, wow, all this is complicated, don't worry, it's all handled in the README, and which is both on the glitch and on the GitHub, so you don't have to. I'm just talking about kind of talking through the design that's built here. So now that those things are out of the way, let's go back to our PowerPoint because the demo has been done. There we go. Okay, so now that you have a very basic idea of how this Teledildonics app works, so you know how to share your toys and how to have someone remotely connect to it, we can talk about how you set this up for yourself. So how can you make your own version of this application on Glitch? Now, like I said, people have downloaded this and put it on Heroku, put it on other systems, and that's fine. Oh, and I am seeing that I might be having some connection issues, so let's see here. Oh. Just curious, can anyone that's watching the stream, is anyone having issues seeing me here? Or, because I just realized I'm experiencing 25% packet loss here. Okay, well, I'm going to go ahead and keep presenting at least because this is being recorded, so I will just upload the recorded version. And if this is choppy, then you'll at least have that, and that should be perfect. So, going back to our web browser, so we have seen how to do this. Here is how we make our own version of this app. So, like I said, don't make your own remote and local the same, but I did that anyways because I'm testing this. And if I go to, okay, so let's make our own version of the Teledildonics app here. So we'll hit Remix Project right here. And what this is going to do is create a new glitch application. So all you're going to need to do is get a glitch account. They're free. And you can go ahead and hit Remix and on the Teledildonics app, and it will bring up a new application. And the one thing it'll clear out is the password file. So if you make a new version of this app or someone forks from you, they're not going to copy your local and remote password. They're going to have to go make their own. And if you try to access the application without setting the passwords, you get an error message. So you will actually have to set that before. Okay, so sorry about that. There was a drop in my connection there. However, it looks like stopping and restarting the stream seems to have very much fixed my dropped frame issue. So I'm just gonna guess that I had a bad connection to YouTube at that point. Anyways. Without further ado, let's get into Teledildonics app architecture. So, like I said, hold on to your butts. This is going to get complicated. So, you might recognize, if you watch the earlier versions, or the earlier parts of my presentations here, you might be familiar with this diagram right here. This is a diagram that I made actually I made it for some presentations quite a while ago, and I just kind of tend to use it these days because it's still valid. So this is what Buttplug looks like. If we were to kind of take it apart and turn it into a diagram. So let's see here. Oh, hit the wrong button. Okay, so you can see my mouse there now. First off, so we have two sides when we're talking about Buttplug. We have the client and the server. The server is what handles actually talking to the hardware. So what happens is you'll have a device subtype manager, and this is what handles, like, am I talking to USB? Am I talking to Bluetooth? Am I talking to serial ports? And it can find different devices across those buses. So we'll have like a Bluetooth device subtype manager, and when you hit that start scanning button, that's the thing that actually scans. And it has a list of devices that it's looking for. That's how when we saw up in the web browser that it was looking for like Levin's devices, and it could see the launch and things like that. That's from that list of devices we provide for it to look for. Once it finds those devices, it creates the device implementation, which you can see also in the server block there, the device impl, and it matches it with a device protocol. So once we've identified a device, we also need to know how to talk to it. So if it's a Levin's toy, we need to send it like vibrate strings. If it's a Curio toy, we need to send it one of the 4 different types of packets they want. And so we match that device implementation, which is the part that actually does like the Bluetooth talking or the serial talking, with the device protocol, which is the part that implements the proprietary protocol, Levin's Curio, WeVibe, whatever else. And we turn those into a device, what we call just a butt plug device. And then the server goes out and tells the client that we have a device. And the way that the server and the client talk to each other are through these things called connectors. A client has a connector to talk to the server, and it can be in process or it can be IPC. So there are situations like, once again, with the server that I just showed, like both the Simple Toy Control app and the Simple Teledildonics app, those are embedded connectors. So what that means is the server and the client are in the same process. But if you're using, say, Interface Desktop, then your client's going to be in the web browser and your server is going to be in Interface Desktop, and those use WebSockets to talk to each other as an IPC mechanism. We're also working on IPC mechanisms through TCP, named pipes, and Unix domain sockets, and WebRTC. So this is going to be just basically the connection layer. And the reason that there is a connection layer that can work as IPC there is that the client doesn't really change very much, but the server changes constantly. The client is just like getting the information that the server is telling it about devices and stuff, but we actually have to implement the devices in the server. So as new devices come out, most of the time we're just implementing the server. There's not a lot of changes to the client. And not only that, when I started Buttplug, we made this promise that it would be backward compatible. So if you build an app and then don't touch it for 2 years and it's using Buttplug, whatever version of Buttplug is 2 years down the road should still work with your app. That's all implemented in the server once again. So if you're running an app with an older client version, it should still be able to connect to Buttplug, whatever it is in the future. And it should still work. Because one of the major problems with sex toy applications is that they're written and then people just drop them. Like they get sick of writing it, some life circumstance comes up, something like that. And they're usually not open source because most people don't want to admit they write this stuff. Once again, due to different life context reasons, family, job, whatever else. So like that kind of backward compatibility is built into the system as an understanding of the context of the software. But anyways, all of this is important now because we're going to use it to hack Teledildonics into the system later. So now that kind of goes through the whole diagram though. Like your application, like say our toy control app, it provides the sliders and stuff, which then talk to the client API. So if I come over here to VS Code real quick, and I actually have the Teledildonics app opened up in VS Code here. So actually, but I'm going to go back over to our web browser first and go to our simple Teledildonics app. This is a little bit easier to talk about. So where are we using our, all of this stuff is application code, and then we're actually accessing a Buttplug device here. This is actually where we're talking to the client. So we're really not doing too much with the client here. All the client does is, so we connect to it here using an embedded client connector and we scan with it. And once again, part 3, I live coded all of this and explained it in real time. So if you're interested in that part, I highly recommend watching that one. But most of this is application code though, and very little of it is really talking to Buttplug itself, because all Buttplug cares about is I want to find the hardware and I want to connect to it and I want to control it. And that's actually not a lot of stuff in your application, because most of what you're going to be worried about is how do I present that to the user. And that's why we have all this other crap about setting up sliders and whatnot. So yeah, there we go. So that's our application, which is built on top of the client API, and then we have the embedded connector for that application. So the server is just inside it, but it could be like we could make it be out in interface desktop or something, and then that talks to the server. The server owns the device manager, which owns the looking for Bluetooth, looking for gamepads, looking for USB. And once we've found those devices, there's the device implementation, which it gets matched to the protocol, which the Buttplug server shows and sends back, and that's how we talk back and forth. That is Buttplug. So the thing about Buttplug is that was what it was designed for, though. That's it's kind of always been assumed that it's I'm just gonna have an application and a server. So we expect them to all be on the same machine, or at least on the same network or something like that. It wasn't really made for a long distance, like clients way over here, servers way over here, because there's all sorts of latency issues and stuff that can come up with that. Sorry, there's a lot of talking, so I'm having to hydrate here. So anyways, Buttplug was designed to kind of just be a local system. And there's really only going to be one user. That user is going to control both the server and the client application. Whatever else the client application does, we don't really know. They could build Teledildonics into it, and it was kind of assumed that the way Teledildonics is going to work with Buttplug was going to be a completely different protocol. So, because Buttplug doesn't really have what I would call permissions, or at least it didn't. So the idea is it's just supposed to go out and find all the hardware and just present it to the user. And then anything beyond that presentation layer, any security or permissions or things like that that would need to happen, would be up to the application implementer. Because we don't know all of the context this is going to be used in, and we can't cover them in our protocol. If we do try to do that, we are going to turn into PostScript. And for those of you that are not aware, PostScript is or something like SVG or something too, where there are languages that contain all of computing, like Turing machines and more, or Turing, multiple Turing completeness all the way up to GUI frameworks and shit. I don't want that Buttplug to turn into that. Buttplug is supposed to stay very simple. It's just supposed to find devices, let people know the devices are there, and control those devices, and that's it. So I didn't want to get security and permissions there. I felt like that should be a layer on top of it. And it was assumed that the app is the terminal point for the client-server relationship too. Anything that the app was going to be doing that might be over a network or something, it was going to define. And then I decided to start this live stream series where I was going to build some sort of Teledildonics app, and here we are now. And this is kind of an interesting thing, because I ended up finding things out about my own framework that I hadn't really thought about. So what if instead of the app having to define its own complete protocol, it could just take the devices it knows about that the servers have told it about and forward them on to someone else? Now, the question there becomes, how would we keep this safe, though? Because the one thing I just fucking said was that I didn't build permissions into Buttplug. Buttplug was just find it, tell us about it, the end. And so that means, if someone's got something like a freaking, eSTEM box or something like that, and you just throw that out on the web for anyone to control, That's a bad idea. So that didn't really seem like a viable option. How would we keep this safe within a protocol that wasn't designed for it? Now, the question became though, was the protocol designed for it? So what we have to ask here is, inside of Buttplug, what is our source of truth? Like, what is the information that we hold? Where does it come from, and why do we trust it? So the information that Buttplug holds is what devices has it found and what are the attributes of those devices. If I have a vibrator, how many, like, let's say the Edge here. This has two vibrators in it. There's one here and one here. So we'll know that it's 11's edge because it told us that through the device name, and I'll go through how we resolve that here in a second. And since we've matched that device name, that gives us information that we've also stored about how many vibrators are in it. So we know that once we get an edge, it's called 11's edge, and it has two vibrators, and each of those vibrators has about 20 steps of vibration. So you can actually set like between 0 and 20 there. And so those are the things we know about that vibrator. How do we know those? Because we've entered them in a configuration file. And that's the thing is, so how does the server trust its data? Because the only thing the server knows is what the hardware tells it. So when we get into our device subtype managers here, so all we know is what a Bluetooth like characteristic descriptor tells us, or what a USB descriptor tells us. Can we trust those things? I don't know. There's no real security there. It's not like you're like cryptographically encrypting any of this descriptor data. There's no key database to match that to or anything else. We're just kind of like, oh, well, we plugged it in, and since we plugged it in, it's got to be secure, right? And that means we can trust it, right? And so that's kind of where that assumption comes in. That is where our trust comes from. We assume that what is in the server is what we got from the hardware. However, you can build your own goddamn hardware. You can put whatever you want in there. We've had people that have taken the information that we use to build Buttplug and have built toys that can spoof Lovin's, Kiru, whatever else devices. Because like one of a question I get all the time actually from cam models is, the cam service that I uses a certain brand of toy, but this other brand of toy works really well for me. Can I make that toy look like the brand of toy that they support? The answer is yes. It's really not too difficult. All you have to do is make your hardware look like another piece of hardware. And that's just a matter of giving it the same name, giving it some of the same identifiers. And if you can make your hardware look like that, and you can make it respond in the way that's expected, then what's happening on the other end of that, we don't know. And neither does the cam service or anything else. So that is where your trust ends. And we can use that fact to build Teledildonics into Buttplug. So yeah, how does the server know any of this is true? It doesn't. Oh shit. So, with that idea of us being able to craft our own devices, how can we use that information plus the Buttplug architecture that I just showed to create Teledildonics? So, I created this idea called device forwarders. And this is how our Teledildonics server runs. So what we have here is this is two Buttplug setups right here. If we start back here, like this side right here is what we would call our local over in that web app. So here is like this down here is our actual hardware. This is like our actual USB, Bluetooth, serial device finders. This is our real server running on the computer that is actually finding some sex toys. And this talks, as usual, to a client. Now, the change that's gonna happen here is the application is no longer our terminal. That's not going to be just our endpoint where we're just playing a game and the game's going to control the toy and we're done. Now, our application actually has this thing bolted onto it that's called a forwarder. So what the forwarder does, and swapping back over to VS Code here to see if I can find this real quick. Okay, so that's the server, yeah. Start remote connection. Give me just a sec to find where the hell I set this up. Start local connection. Here we go. So what I do here is I create a thing called a yeah, I'm having to read my own code again here real quick. So yeah, so we're starting our local connection here, and then we create our forwarder, and I'll get into what that is here in a second. Oh, here we go, setup client. Yeah, so whenever a device is added, so whenever our server tells our client that there's a new device it can use, we go ahead and create our controls div for it. So that's like the thing that has the slider and the share control and stuff in it. And what's going to be important here is the share control button. And I just have to remember where I put that. Create linear, create device controls div. Here we go, can share. So what happens here is once you click that share device button like I showed in the demo, we send the device to the forwarder. And so the device itself is this thing that's that is a buttplug client device. If I bring up my web browser here and go to Buttplug.js docs, okay, so we're going to send the, what we send to the forwarder is a buttplug client device. And buttplug client devices, and I'll just turn my webcam here too. So this has all the information about what a device can do, as well as a way to control it. So we send the forwarder this object, and it says, here's the allowed messages. And allowed messages are things like, this can vibrate, this can rotate, and it can vibrate with this many steps, it can rotate this many steps, so on and so forth. And then there's a few different ways to actually send those commands. So we just send the forwarder that information, and then going back to PowerPoint. So okay, so that's what our forwarder does. Like, we have the client has those those buttplug client device objects, and whenever you click share, it sends it through the forwarder. What does the forwarder do? The forwarder is a WebSocket connection to a remote system. So this is, what this does is it causes the client to create a WebSocket connection to a node server running on Glitch. So we are now outside of our own network. We are talking to the server. And so we send this device to the remote server. The remote server is actually a buttplug server, and instead of its device subtype managers being USB or serial or Bluetooth or one of the hardware communication buses, It's now just a shim that's taking these remote serialized butt plug client devices and making them look like they are an actual butt plug hardware device. And there's all sorts of interesting stuff that we can do with that fact that I'll go into here in a second. But for now, you can just kind of trust it. It's like the same thing that you're running this server locally, but this server exists remotely. So all of this part right here exists on Glitch. And then when you want someone to remotely connect, so when someone actually puts in your domain name and that password and they hit connect, that's where this connection right here comes in. So this is going to be their local machine, but they're connecting over the network via like this. This connector right here is embedded. This connector right here is going to be WebSockets because this all exists on the Glitch server. So that's device forwarding. We are actually using the structures inside Buttplug and the ability to craft those structures in order to make a Teledildonics interface that actually has some sort of permissions. Now, you might be asking, well, where are those permissions? And I'll get to that in a second. So this does create kind of a butt plug centipede. And right now, also, I've only built these structures in Buttplug.js. They will be coming to Buttplug Rust, but I've had to finish up a few other things there first. But it's very important that they will be in the Rust server for some topics I'll go into here in a sec. So where is the Teledildonics? So here's a breakdown of what I just talked about in sort of a better way. So we have the local controllee, which has the embedded connector and everything else. This is our forwarder. And so this right here exists on Glitch. This is part of, if I go back to VS Code, so there's the server.ts file. Once again, heavily commented, and there's three different, this is basically a WebSocket server with three different endpoints. So there's the base endpoint that just brings up the app itself. So when you're actually seeing that HTML page, that's that. And then there's going to be the forwarder endpoint, which is what the local side uses to, actually no, yeah, that actually is the root endpoint is a dual use endpoint because it is HTTP. If you go for it over HTTP, it will give you the web page. If you go through it over WebSockets, that's how your remote controller actually accesses the server. So that would be that right there. Oh, I'm sorry, I hit the wrong. Okay, so this right here is the WebSocket that you would access through the remote. God damn it. Yeah. Well, the blue line is what you would access through the remote endpoint. Anyways, this is all explained in the comments here because I'm doing a poor job of it. So then there's the forwarder endpoint, which is what the local connects to forward its devices over. And then there's a status endpoint. This is special just for this application because I needed a way to be able to tell the local that a remote had connected. So I needed an extra endpoint to give that information over. And I'll talk about why here in a sec. It has to do with some of the eccentricities of the Buttplug protocol. So anyways, there's all these endpoints that are kind of connected together now using WebSockets to make all of this happen. And so this, yeah, here we go. So this part all lives on Glitch in TypeScript. And then this is just, once again, this is part of that index.html and script.js again. So both the local and the remote are the same code base, and they both hit this server. It's just depending on which WebSocket endpoints you're using and which parts of the UI you're using, you get a different experience. So that's kind of how the Teledildonics is put together here. Now, what does forwarding devices really mean? So you can actually pick which devices you forward, unlike Buttplug's normal model where it's just going to find every single device it knows about on your system and present it to you. You can say what you want to share. Like in the in the UI, when you hit share devices, that's you doing that specifically. You are saying, I just want to share this certain device. Um, with There we go. And since you're crafting a device, you can also craft the capabilities there. This means that if you don't want someone knowing that you're using 11th DOMI or something like that, you can actually change the name. And our mappings between that will match up. So all the remote user is going to know you have is vibrator or whatever the fuck you type in if you have the interface to do that. We do not have the interface to do that with the Teledildonics app currently. It will leak the information of what your toy is. But if you wanted to change that, that is something you could change. You could also change the range of movement or something like that. So once again, with Eleven's toy, if you only wanted it to vibrate for 10 steps instead of 20, that's totally a possibility. So you could just set that up to say it will only work for 10 steps of vibration or something like that. So you can create a subset of the device capabilities that you can then share with someone else. And that's where your permissions are. So instead of just exposing the whole system to everyone on the net, whoever it is, you can craft a very specific subset. And it is up to Buttplug to actually keep all of that straight. Whether Buttplug will actually do that is a really good question. Because in discovering that these structures were possible through this, some other things did pop up that do now need to be fixed. That's currently there. I'm currently logging bugs on that right now, and we'll be continuing work on that as time goes on. So, talking about how we find this stuff in the first place, I was going to go into our device configurations real quick. So, the way Buttplug knows about devices is through a thing called the Buttplug device config. If you actually go to and let me switch over to my web browser here. Buttplug device config.buttplug.io. This will actually pull up a JSON file. And this JSON file has all of the information about all of the devices we know about here. So the version that's up currently is our version 1. We're going to be moving to version 2 soon. And if I go back over to PowerPoint, you can actually see what version 2 looks like. So this documentation on the side over here this shows you, whoa, oh, I didn't know my mouse wheel would do that. So if you look at the right side of the panel here, this shows the Kiru version 2 device configuration in our version 2 device configuration format, where not only do we have the Bluetooth information of the device names, their services, characteristics, all of that stuff, we now have information specifically about the type of messages they'll take. So linear CMD is the way to move back and forth, which is like, this is what the Fleshlight launch would be using. What you're actually seeing here is a definition for the Fleshlight launch. So it can move back and forth with a step count of 99. I don't know why, but Kiru just decided that there's 99 steps from the bottom of the launch to the top of the launch, so that's what we put in there. And we'll also be adding, like, you can actually see some of the new stuff that we're still working on adding, like the battery level and whatnot. So you'll actually be able to figure out how much battery the device has. But anyways, this is like our base configuration. This is what you start with when you are crafting a device configuration. And what you'll be able to do in the future once we have like a real Teledildonics app is it will take this configuration, present it to you, and then say, what do you want the other user to see? Do you want them to know you have a launch? Do you only want it to be able to go like a certain subset of the total distance it can? Which is super useful too, because bodies are different, like penis sizes are different. People are going to have different interests in like clitoral stimulation levels and whatnot, and you need to be able to set that. And this means that not only does it mean you can say don't go faster than this or whatever else, it also means you can actually set it specifically for your body so that the other user isn't having to guess what the best setting is for you. So there's a combination of both usability and security within this sort of device crafting approach that I think will be really useful in larger applications going forward. So for the server itself, that's running on Glitch, I already talked about this a little bit. It's a Node server written in TypeScript. Right now, running on Glitch because it's very easy to test that. I actually built it locally and was running it off a local port too. That works fine. There's a package file in there with all of the npm commands needed to do it. I usually build on Yarn. This time I just built it on npm just to make life easy. So you can basically just check this out from GitHub or remix it on Glitch, and you're up and running and can easily do iterative testing and adding more features to it if you want. It uses WebSockets currently, so like I talked about, there's multiple endpoints. I'm using the Express node package to do this with Express WS for the WebSocket handling. I don't really know how that's going to scale or anything else. I don't really plan on it scaling. Once again, one-to-one application. I'll talk about larger scale scaling here in a second. But for this, just making life easy, like you're talking for a fully connected system, a grand total of 3 WebSocket connections. You've got the local talking to the forwarder to send devices over and get commands back. You've got the local talking to the status endpoint just to figure out whenever the hell the remote's going to connect, or whenever the remote connects. And then you've got the remote talking to the server to actually be controlling the local's toys. Now, we don't need that middle server in Glitch. As I've said multiple times, we could be using WebRTC here and do this P2P. Now, the thing about WebRTC, for those of you that are not familiar, WebRTC is sort of a set of technologies that you can do audio-video conferencing with. So say if you wanted a Skype or a Zoom in pure web technologies, that does exist. For all of you that might have heard of people screaming, use Jitsi as Zoom has had security issues during the COVID-19 pandemic. Jitsi is WebRTC based, and so it's an open source thing. It's a nice technology. It's pretty cool. And the thing is, once you're connected to someone else, you are connected directly. Like you are talking directly to each other without having to worry about port forwarding on routers or anything else. The one thing is you have to both talk to an outside server in order to create that peer-to-peer connection. And so I haven't really figured out how I want to talk about all of that and whatnot yet. So I just went with, right now, you host everything. Yes, your server still exists on Glitch or where Heroku or DigitalOcean or AWS or wherever you put it. So you still got some remote there that you're going to have to manage. And WebRTC would be less of that because you just create the connection and then it's all you talking back and forth after that. But there's a lot of metadata and stuff that could be moved around, so still figuring all that out, but it's an option. So the remote. The person that is controlling the remote part, it is just a plain old butt plug connection. There is no special thing being done here. I had to add no code to do this. The connector just connects to the Glitch server and gets the forwarded devices, and we're good. So that's it. There's not a lot to say about the remote there. That was actually the easy part. It was presenting these devices in a new way that was the part that took all the time. So what is our security here? That's a good question. So for the app that I just showed, as you saw, it uses really simple but password-based security. So you just type in 2 passwords to a file that it loads. We are expecting this to... Oh, okay. I got a little ahead of myself there. But we are expecting the passwords to fly over HTTPS, so TLS. So that is, like, they won't be in clear text over the line. They won't be man-in-the-middleable. But there's 2 different passwords too, so that you have to give someone else the password to connect to the remote side to connect to your toys, but they also can't connect to your local because you have your own password. Unless you set them the same, don't do that. But anyways, that's it for security, though, really. So how are we sending those passwords around? That's kind of an interesting part, because this is yet another hack on top of Buttplug's current architecture. So we do this via the connectors. Now, connectors were made with the idea that they would only ever be flowing the Buttplug protocol. And the Buttplug protocol is a very specific set of messages that are defined, and we actually check their definitions and whatnot as they fly over the line. So there's no password message in Buttplug. There's no authentication message in Buttplug, because, as I stated earlier, we didn't want that much. Like, we didn't want to add a whole authentication layer to what was only supposed to be a hardware system. So, how do we fly passwords over a connector that's only supposed to be for Buttplug? So it turns out that there's kind of a gap in the line. Connectors have to send this message called request server info to kick off a Buttplug connection. So once you connect to a server, that's the first message you're supposed to send to start Buttplug. If I go into our web browser here and go over to our, so this is the Buttplug protocol specification document, and if in this in the architecture portion, like, yeah, and go to this at Buttplug spec beta. This is the beta version, so it's for the version that's coming up. Buttplug spec beta docs.buttplug.io. In our architecture portion here, and this is linked from the buttplug.io website too. We talk about the life cycle of a Buttplug connection. And as you can see, the first step here is, once a connection is established, perform the protocol handshake. So it's telling you the first thing that you're supposed to do is send the protocol handshake. But what if you don't? So that this is like, this whole Teledildonics application has been a constant questioning of, well, we're supposed to do that, but what if we didn't? And so that's how our password authentication works. Instead of sending this request server info and getting server info back, we have our own little mini protocol that exists before all of this. So going back to PowerPoint here, so we can send anything we want before request server info, as long as the other side is also expecting us to send anything we want. So after request server info is sent, like, the server loop is then running, and anything that is not a Buttplug message will be kicked out. But until that point, connection's ours. So this is how password authentication for the Teledildonics server works. The first thing that we fly over that line is the password. We send the password, the server just sends back a literal OK message. That's it. And all of this is message delimited as part of the WebSocket protocol too. So we just get a string of OK, and then we're like, okay, good. We've made our connection. That's fine. If our password is wrong, the server just shuts down the WebSocket connection. But if the connection does stay open, at that point we send request server info, and we've actually created the Buttplug flow. So we can continue using that protocol and being either a device forwarder or a remote connector that's controlling toys. So, is this really security, though? That's a very good question, because Buttplug, not initially meant for this, which is not an excuse. This still needs to be secure, and I have found a lot of things here that it sucks for. So, because the problem here, and what I went through in the earlier slides, is that we trust hardware. We trust hardware a lot. The whole reason we can do this is because we trust hardware a lot. We shouldn't do that. Buttplug very much needs fuzzing and needs better hardware testing to test for more boundary conditions. So, like, right now, if you wanted to say, when I talk about crafting devices, a device that goes to the forwarder is just a JSON packet. you can send 2 GB worth of string in that JSON packet or something, and who knows what's going to happen. It's going to suck for me. Um, or you could say, oh, hey, this device has 4 billion vibrators on it, as I show in the image next to it from Dongpocalypse. Um, so, um, if that there is all sorts of boundary conditions we need to be testing on as the system has been recontextualized for being a mediator of remote intimacy, and that's going to be happening soon. But it's going to take some time, and so the current version of this, if you push it, it will break. And it will break in weird ways, and that very much needs to be known when using this. So depending on who you are trusting to give your remote password to and the domain name, if they know this and they want to fuck with you, that can happen. Um, and that's why all this is open source, and I need help. The plan right now is to implement a lot more of this hardcore checking in the Rust version, because once again, we want, like, my goal is to have all of that core logic in the same language and the same code base that we can then use everywhere, so we only have to do this once again. Trying to do this across Rust and C# and JavaScript is really untenable. Like right now the developer team is 1, but even if it were 10, that's still so much synchronization that it's really not worth it. Yeah, coming soon as part of Buttplug RS. And honestly, if you're really interested in hardware security stuff like this, I highly recommend following people like, Travis Goodspeed, Kate Temkin, White Clark, McScott, a whole bunch of other people on Twitter that are really involved in like the interesting parts of hardware security. Not specifically Buttplug based, but that's what I do. Okay, so that is how the system works. That and in some ways doesn't work. Um, how does this scale though? Because that's where some really, really interesting aspects of this come in. Um, with the Teledildonics app that I showed and designed, it's 1-to-1. The only reason that restriction exists is because I put it there. There is nothing saying that we couldn't have multiple clients here, all talking to the same server that are all talking to the same remote. So we can have, and this diagram is actually incorrect. Like all of these should just be pointing at the same device subtype manager, because the device subtype manager can handle multiple WebSocket connections from multiple clients. So you could have 3, 4, 5, 6 people all connected to the same remote server instance, and then one um, remote connector controlling them all. And you probably wouldn't want to do this for an in-person interface. You certainly could. And for something like FinDom or group, like a group BDSM or swinging or something like that, it would be super useful if you did want a single person, human in the loop there. However, if you wanted to hook up a Telegram bot or a Discord bot or something like that, this architecture would work really well for that, because then at the end of this other line is going to be the bot. And so you could say like each server is a chat room or something like that. And that allows you to actually have the aggregation and control to a bot or something like that. That would make that it would basically just work, because a computer, uh, doing that kind of control computationally is totally viable, and it's a good architecture for it. Not only that, there's nothing saying that you can't run multiple servers in the same cloud instance, and this is where we start thinking a little bit more about like multi-layer fan out and whatnot. By using multiple servers, because all of these servers that are sitting in the cloud are incredibly lightweight. These are all a set right now of WebSocket connections. They don't have to be WebSocket connections. For instance, if I were to design the one-to-many here that I just showed in this slide with the Discord bot or the Telegram, Discord and Telegram are not super quick ways to communicate with bots. Like it's not like you're gonna have like a slider come up in chat that you can move around. You're gonna have to type things. If you're gonna have to type things, it's gonna be slow. If it's gonna be slow, you don't really need the statefulness of that connection that you would through a WebSocket. So you could actually make a stateless HTTP connector here. And that would really, really reduce the amount of bandwidth and processing that you would need to do instead of having a WebSocket connector, which is going to be stateful and have to keep the ping messages and whatnot going. So there's all sorts of changes we can make to the connector system to keep state even over stateless protocols via UDP, HTTP, whatever else. And then you can just multiply the number of server instances on your server, and suddenly you have a full Teledildonics, like a full multi-user Teledildonics system. And this is how you would build like a large commercial system. ButtplugRS is made to scale in this direction. It is using async. So if you wanted to run hundreds or thousands of servers, it should be possible. I haven't tried it, but most of the thread generation in ButtplugRS exists specifically for hardware devices. So there are times where I have to create a thread, like I can't run it pure async because it's going to block. For the serial port implementation, I just had to do that. For I think there's a couple of places in our Bluetooth implementation right now where we can't pull quite yet. So, but when you're running Buttplug and Rust on a server, there's no hardware. Everything is a virtual device. So at that point, it's just going to be tons and tons of network connections, and you can scale those connections easily. And the thing is, like, you will probably at that point want to run it on something different than Glitch. Like at that point, I would probably run it on a droplet or something like that. But um, or it is possible for it to still be on Glitch because Glitch just put out a new boosted app system, so you can actually get a Glitch app that will not sleep. And Glitch gives you a full VM, so you can build Rust and stuff on there too. If you want to do it in Node, you can do it in Node, and that's what their system is built for. But you can also do it in other languages too. So you could actually host this on Glitch if you wanted to. That is kind of up to you as an architecture point. But anyways, that is kind of an overview of how this works and where it can go. And with that, if anyone on the YouTube channel has any questions or anything like that, I'm gonna open it up for questions now. Got 10 people watching apparently. Otherwise, that's pretty much all the information I had. So now you know how to bring up your own Teledildonics app, how you could possibly build your own Teledildonics app, and even your own Teledildonics service. Part 4 is finished. Yay! Um, so just gonna open it up for any more questions here and get to wait for the buffering to catch up. Okay, well, it doesn't look like we have much in the way of questions here. So if you do have any questions after this or you're watching it later or something like that, feel free to either hit me up on Twitter or pop on our Discord. Or there's multiple ways to get a hold of me. Happy to answer questions about this stuff. And definitely taking uh, bugs and issues on the server too. I've already had a few of our beta testers turn in some bugs. Would also love to know if you take it, fork it, make your own thing with it. Please let me know. Happy to retweet about that. Love to see people extending this stuff. So yeah, with that, I think I'm gonna sign off and go back to doing nice recorded videos that I can edit and don't have streaming issues on. Thanks so much for joining, and until next time, keep butt plugging.